All right, so today we're going to look at 9.2 part 1. And this is on a third type of graphing we're going to do on the calculator called polar. Both function notation and parametric use this type of coordinate system. Let me just get an example like that. Doesn't matter if you're using parametric or polar. Everything is still based on an XY axis system, or parametric or function. When we get into polar, okay, that's the new one we're going to do today. Polar, not only is the equation written a little differently than what we're used to, but it doesn't even use the same grid system. Polar uses a system like that. So it uses a different kind of grid when you do the graph. At least parametric still use the same one we're used to, but polar doesn't. So we've been using a rectangular coordinate system. Now I'm going to show you how to do a polar system. We're not really going to get into graphing today, complicated pictures. We're really only going to get into graphing single points. That's it. Just like when you learned how to graph 3, 5. You go 3 right, you go 5 up. You have to learn which way to go. That's basically what we're going to learn how to do in polar. Okay, I will show you something pretty quick. In parametric, if you want to draw a circle, you could type in something like this. 3 cosine t, 3 sine t. Set your parameters 0 to 2 pi. And this is a circle with a radius of 3. So I'm going to go negative 5 to 5 and negative 5 to 5 and hit graph. And it is a circle. If you count the tick marks, it's 3 units in each direction. If you want me to make it look better, there you go. So that's the amount of work I need to do to draw a circle in the system we learned yesterday. So that's parametric. So look at what I had to type in and the stuff I had to adjust. Now, let me go to polar. If I want to draw a circle with polar that has a radius of 3, I'm done. All I have to do is type in a single number for the equation. I'll check the window, but I think the window looks fine. There you go. The point here is I'm trying to show you in polar, it was a lot easier to do this circle because I didn't have to type in as much. In parametric, it's not as easy. So polar is a good system for circles. It is not a good system for lines. We can do lines in polar, but we already have a simple way to do lines. That's just the y equals mx plus b. You want to do a line? That's probably the best way to do it. Polar, really complicated for lines, but not for circles. So circle is an example of something that can be drawn much simpler. This is what the polar system looks like. This point at the center, they call that the pole, or you could also call it the origin. A lot of times they call it the pole. And there's really only one axis in polar. Like in XY, you have 2. In polar, you just have this one. And that's called the polar axis. Every point that we graph in polar is going to be measured using 2 numbers. A distance from the center and an angle of rotation with the polar axis. That's how graphing a point in polar works. It's a distance you move out from the center and then an amount of rotation. So in polar, you have 2 points, but they're not an x and a y value. They're an r value and a theta. R stands for radius, and it is a distance you move out from the origin. Theta is an angle that controls an amount of rotation. Now, there's really 4 cases that can come up here. You can have a positive radius and a positive angle. You could have a positive radius with a negative angle, and all the other combinations. So what we're going to do now is, how do you graph a point in polar? Well, it's like graphing an XY point. First, you deal with the R. Then second, you deal with the theta. R is kind of like X, right? If R is positive, you're going to start from the pole and you're going to move to the right, however many units R is. If R is negative, you're going to start at the pole and you're going to move left. So in that sense, it's very similar to what you would do for X. Now, theta is nothing like Y at all. Theta has nothing to do with movement up or down. Theta has to do with rotation. And when you think of rotation, what are the 2 directions you can rotate in? We don't really say up or down. Yep?
Left and right. Or clockwise and counterclockwise?
Clockwise or counterclockwise. Yep. So theta is going to now tell you how many degrees to rotate after you do step 1. If your angle is positive, you're going to go counterclockwise. Okay, counterclockwise is this way. If your angle is negative, you're going to go clockwise. That's that. So positive angles, counterclockwise movement. Negative angles, clockwise movement. And again, that's after you do step 1. Questions on that? Okay, let's try some examples. So what you could do, a lot of these problems you're going to need a piece of polar graph paper. You could just Google it and print one out, or if you just draw it once, you can put all your answers on the same graph. Just label which one is which. Like, this is number 1, this is number 2, things like that. All right, so our point is 345 degrees. Now, what's my radius in that? 3. Yep. And Abigail, because it's positive 3, which way am I going to go? Right. Yep, we're going to go right 3. I'm going to put a temporary mark there. I'm going to erase that, but that's just marking that I went 3 units right. Now, from here, I need to rotate. Jack, how many degrees am I going to rotate?
45.
Yep, we're going to rotate 45. And Casey, because it's positive, what direction? Clockwise would be if it was negative. Counterclockwise. So 45 degrees rotates you halfway through the quadrant, and that's what your point should look like. On the test in Elastic, the way it'll be set up is you'll have a grid on the screen, and I'll ask you to graph a point. You basically just take your mouse and you click wherever you want, keypad, whatever you use, and just click where you want the point. And then you can drag it if it didn't go where you want it. Okay, questions on that? All right, let's try this one. -2, 75 degrees. Eli, what's going to be my first step here to deal with the -2?
Move left 2.
Yep, move left 2. So now, starting from this point, Francesca, what am I going to do?
You're going to go clockwise,
Okay, how much?
75 degrees. Oh, it would only be 25 degrees, right? I mean 45 degrees, right? Because it wouldn't be if it's 75 halfway.
So this number is the amount of rotation you have to do. So we do have to rotate 75 degrees. But which way is it? You just have to figure out if it's positive or if it's negative. That's what it tells you. Yep, now. It's counterclockwise. That's a positive 75. So from this spot, you're going to rotate 75 degrees counterclockwise. 75 degrees would probably put you about right there. Questions on that one? All right, let's try this one. 3, -60. All right, so Ethan, what's my first step?
Go right 3.
Yep, we're going to go right 3. And then, Chris, what am I going to do from there?
You're going to move clockwise 60 units.
Moves clockwise 60 degrees, rotating 3 units up. So that's going to be probably about right there. Questions on that one? Let's try this one. -4, -3 pi over 2. It's not necessary to do this, but what do you think some people might find easier if we did it in this problem? Presley?
Change the radians to degrees.
Yeah, you might want to change the radians to degrees. If you can graph it without doing it, that's fine. If you need to, then let's do it. What's -3 pi over 2 in degrees?
Like -270.
That's -270, yep. Okay, let's graph it. So Tyler, what's my first step to graph that?
Find the -4.
What's that?
How did you find the -4?
What do you mean find it?
Like, on the graph.
Yeah. So how can you tell me where that's telling me to move?
Does counterclockwise move? Clockwise?
So the radius doesn't give you clockwise or counterclockwise.
So
That's
just left
that's just left. How many?
4.
4. So we're going to start by going left 4. And Bailey, what do I do from there?
Move clockwise,
How much?
-270.
Go clockwise 270 degrees. And Jake, where's that going to put me if I go clockwise 270 from there?
So it'd be, did you ask where it's going to be? Or just like
Yeah, where it's going to be.
right at the bottom? The bottom, like, line pointing down.
Yeah. If you go clockwise 270 degrees, you land right there. So the way we got to it is we went left 4, and then we rotated around clockwise, 270 degrees. All right, can someone give me another way that I can get to that same point, besides -4, -270? Yep.
Would it be like 4 and 90?
4 and how much?
90 degrees?
That would
Or
put me up
negative
here.
90 degrees.
-90. So 4, -90 would do that. Third way. Yep. -4, +90. Left 4. Yep. +90. One more way. If you look at the pattern, you've got a negative, negative, positive, negative, negative, positive. You're missing positive, positive. Probably the most common way that you would do a graph. Yep. 4, 270. So you have 2 ways to get there by going right, 2 ways to get there by going left, clockwise and counterclockwise for each one. So that means in polar, there are up to 4 basic ways to get to a point. Up to 4. Some only have 3. An example of one that would only have 3 would be something like this. Because you could say you could go right, but then there is no clockwise or counterclockwise because you're right on the axis. So a point like this only has 3, but a point like that has 4. Compare that to this. If you wanted to tell me the exact coordinates for that point, how many different ways are there to write the coordinate? Yep. 1. In rectangular, there is only one way to specify a location. In polar, there are up to 4. And the reason I show you that is because when we get into doing problems, if you get an answer like this, and maybe on the test I write this one, and it was a matching problem, you would have to know how to change your answer to one of the other 4 ways. Now I think the easiest way to do it is just to make a sketch. You could probably figure out formulas like, okay, if I take this and it's a -90 and I add 360, I get 270. So there are patterns and you could try to figure out formulas, but I think a sketch is the easiest. So questions on that idea? Okay, so that's that. How about 0 pi? Where do you think that point's going to end up? Yep.
It's going to be at the pole.
Yeah, it's going to stay at the pole. So what you want to do for this one is you put a point at a radius of 0. And then when you click it, pi is 180 degrees. So you want to take the point and rotate it 180 degrees, just like that. And I can tell if you, when we did tests on paper, if people did that, I looked for what I call the spin factor. So when you put your pencil down and you spin it, I could look at it with like a magnifying glass, and I could tell if you actually spun it or you just did it like that. That's what I would check for. I'm going to check for the spin. So 0, anything is always right at the pole, right? That doesn't change. How about something, 0? Is that at the pole? Francesca?
Wouldn't it just stay at the 2.5?
Yeah, it's just going to go right 2.5 and stay right there. Okay, so anything comma 0 is on the polar axis. You move left or you move right, and then there's no rotation. Okay, questions on that? So that's basic graphing in polar. We already did that. So I explained to you this already. There's up to 4 different ways to graph a point in polar. So we talked about that. And now the last 2 things we're going to look at is how can you change a point from polar to rectangular, and then we'll try the other way as well. Can somebody tell me in polar, what are the 2 things called that they give you? They give you this, and they give you that. Yep?
Radius and angle.
They give you the radius, and they give you the angle. And when you write a coordinate on a rectangular system, what are the 2 things called that you have to have? Yep?
X and Y.
You need an x and a y. So our goal is to take an r and a theta and convert it into an x and a y. We've done this kind of thing several times before. It's going to be very, very similar to something you've seen. Okay, so pretend like you've got a point right there. If that was a point in polar, you would know 2 things about it. One would be the radius. That's the distance from the origin to where that point is. The other thing you would know is how much rotation did you do from the polar axis, and in this case it's in a counterclockwise direction. It's a positive angle. So that's polar. Now what we want to do is change it to rectangular. Rectangular uses horizontal and vertical distance. It doesn't use a degree of rotation. So what do you think I'm going to do to this diagram to help me visualize the horizontal distance I move and the vertical distance I move to get to this point? So I want to figure out what I'm going to add to this diagram so that I can visualize the horizontal distance I move over from the origin and then the vertical distance that I move up to get to that point. Yeah?
You're going to make a right triangle.
Yeah, we're going to make a right triangle out of that. And the way we're going to do it, really, you just need a vertical line. Just put it in right there to make a triangle. And now we can see the 2 distances. The base of the triangle is the horizontal distance from here to here. What part of my coordinate would that length of that green line be? Yep, that's my x. And then from there, I go up to the point. That blue would be my what? Yep, that's my y. So now this just comes down to figuring out the base and the height of a triangle. That's how you convert polar to rectangular. Find the base, find the height. Let's start with the base. X, R, theta. What side is x relative to theta? What's its position? Yep, it's adjacent. And what about the r? Yep.
Hypotenuse.
Hypotenuse. And what trig function has adjacent and hypotenuse in it? Sine, cosine, or tangent? Sarah? Cosine. So the cosine of my angle equals adjacent over hypotenuse. My angle is theta. The adjacent is x and the hypotenuse is r. If you solve that for x, get x by itself. Can anybody tell me what would be right here? Yep.
R cosine theta.
There you go. That is the formula to calculate the x value of a rectangular coordinate from the polar. And we could go through the same thing again, but anyone have a guess what the y formula is going to be? Yeah?
R sine theta.
It's r sine theta. That's the formula to calculate the y value from a polar coordinate. Now notice the trig function we didn't use. We didn't use tangent. Well, we'll come back to tangent in a minute. But that's all we need for right now. Okay, so let's try that on a problem. Let's do this one first. There are two special numbers that can come up when you're converting polar to rectangular. If you're dealing with an angle that is a multiple of 30 or 45, we need to write the answer as an exact value. And the two special numbers that you could see are 0.707 and 0.866. People remember seeing these two before when we studied 45s and 30s? This one, as an exact fraction, is the square root of 2 over 2. That will only come up if you have an angle that's a multiple of 45. Does anybody remember what 0.866 is? It has a square root in it, but it's not square root of 2 over 2. Anyone remember the other square root that comes up when you're dealing with unit circle? The square root of 2 comes up a lot. And then the square root of, yeah?
Is it 2 square root of 2 over 2?
That would just be square root of 2. That's what you get if you flip this. And that's the number 1.4, but you're not going to see that number come up in this case. But it does come up when you do like cosecant and secant. But we're just not doing those right now. Okay?
So it's square root of 3 over 2?
It's square root of 3 over 2. So keep in mind, if any of those two numbers come up, you need to write them as an exact answer. So let's try this and see what happens. Right, what's my formula for x? What times what? Yep.
R cosine theta.
R cosine theta. No reason to change that to degrees. I would just leave it. It's fine. And what about your formula for y? Yep.
3 sine theta.
3 sine theta. Did you say 3 the first time, Ashley?
No, I said R.
Oh, you said R.
Yeah.
I think I was thinking of the 5. But it's 3 cosine 5 pi over 6, 3 sine 5 pi over 6. 5. Now, my advice is, if you want to see if one of those special numbers came up, don't type this in all at once. You'll never see it. If you're going to get a special number, it's going to come from this. If you triple it, you'll never recognize it. So just do cosine 5 pi over 6 first. See what you get. Cosine 5 pi divided by 6. I got negative 0.866. What is negative 0.866? Jeff?
Negative square root of 3 over 2.
So that's negative square root 3 over 2. That's the part, actually let me write it like this. That's the part that's in the box. You still have times 3 in front. So just put times 3. Just like that. Now, the next one, sine 5 pi over 6. If one of them comes out to the special number, the other one won't. They both won't come out to the special number. Unless you're dealing with a 45. Then it will. But with the 30s and 60s, nope. So this one is just 0.5. So this is a half times 3 is 3 halves. Okay, so 3 halves. And that's it. Just write your coordinate. Negative 3 root 3 over 2, comma, 3 halves. And that's how you convert from polar to rectangular as an exact answer. Questions on that one? Now, this one is not a multiple of 30. It's not a multiple of 45. So you're just going to type it in and see what you get. And you're going to round. I can show it to you. Take the cosine of negative 200. 0.487. That's not a special number. Right? So 2 cosine negative 200. There's your x. 2 sine negative 200. There's your y. X equals, y equals. There are no special decimals there because it is not a multiple of 30 or 45. Let's just write it as a coordinate. 0.97. Oh, what did I do wrong?
You calculated in radians.
Yeah, I left my calculator in radians and I had that in degrees. So I typed everything in, okay? Put it in degrees first. So x is negative 1.88 and y is 0.68. Now we're in degrees. That's an easy mistake to make. You don't want to make that mistake on the test. Or at least if you do, hopefully you catch it like I did before you finish the test. Negative 1.88, 0.68. That's your x, and that's your y. Great. Questions on that one? Okay, so the last thing we'll look at, and that'll finish up, is converting back the other way. So the last thing is rectangular to polar. Okay, we're going to do the same kind of thing. What are the 2 letters they give you in rectangular? Ashley? X and Y. And what are the 2 things you want in polar? Yep.
R and theta.
R and theta. So now they're going to give you a point like that, and you are going to know how far over and how far up you went. But you're going to have to turn the over and up into an amount of rotation. So you need to find this angle and a distance from the origin. How could you get r if you know x and y? R is the distance from the origin. Yep.
Pythagorean theorem.
Yep, and we're going to write that down in a minute, but you're going to use Pythagorean theorem. And what trig function relates the x and the y? Yep. Tangent. So I said, remember we didn't use tangent. We're going to come back to it, and I'll show you switching it. That's because we're going the other way. Now, if you use tangent, you'd have this. Tangent is opposite over adjacent. And that's true, but we want theta. We don't want tan theta. So how do you get rid of tan? Yep.
Take the inverse tangent.
Take
all
the
sides.
inverse. Yep. Take the inverse tangent. Okay, I'm going to write that down nicely on the next page. But that's the idea of where the formulas are coming from. Inverse tangent and Pythagorean theorem. Alright, so to convert from rectangular to polar, step one is figure out the quadrant you're in. And you might say, well, why does the quadrant matter? It does kind of matter, and I'm going to show you. If you graph it and you end up in quadrants 1 or 4, you can use inverse tangent of y over x. That formula works perfectly fine. The problem with just using inverse tangent, if you remember when we studied it maybe 2 chapters ago, inverse tangent only gives you an answer between -90 and 90. That means you're either here or here. This is quadrant 1, this is quadrant 4. Inverse tangent will never give you an answer in these 2 quadrants. If it doesn't give you an answer in those 2 quadrants, you can't use it to calculate a point in those quadrants. It won't give you an answer there. So what you have to do is, if your coordinate is in quadrant 2 or 3, basically if your x value is a negative, doesn't matter if you go up or down. If x value is negative, you're going to be in quadrant 2 or 3. If that happens, you take your formula and you add 180 to it. That's only for quadrants 2 or 3. If you're doing it in radians, you can add pi. It's the same thing, but we'll probably do it in degrees, the example I show you. And now these 2 formulas cover quadrant 1, 2, 3, 4. But where else could you be besides in quadrants 1, 2, 3, or 4? And this could be a little bit of an issue. Yep.
On the axis.
You could be on an axis. Pretend your point was right there. And I wanted you to convert that to polar. Well, I don't know the y value of this point. All I know is it's some y value up. But I do know the x value. What's the x value of that point? Yep.
0.
0. And look at where x is. X is in the bottom of a fraction. What number are you not allowed to plug into the bottom of a fraction? 0. So if x is 0, you can't use these formulas to figure it out because you'd be dividing by 0 when you fill it in. So what do you do if you're on an axis? You just have to memorize it's one of those 4 answers. 0, 90, 180, 270. Just have to memorize those 4. And now it covers everything. So that's how you find your angle. And I told you I'd write down how to do the radius, but somebody already said it. It's the Pythagorean theorem. Here's your point. You have a triangle. You'll know x, you'll know y, and you have to find r. X squared plus y squared equals r squared. All right, so we'll try one example of this, and then that'll be it. When you're converting, it doesn't matter if you do the radius first or you get the angle first. If you want to get the radius done because you think it's easier, it's fine. You can get that done first. Right, so here's your point. 3, -5. And this is rectangular, okay, because it says convert to polar. So if they were giving you something in polar, you'd already done it. So that's rectangular. Where's 3, -5 when I graph it? Doesn't have to be exact. I'm just looking roughly quadrant, Matt.
4.
Quadrant 4. Like down there somewhere. 3, -5. When I'm trying to find theta in quadrant 4, do I add 180? No. Don't add 180. Just do inverse tangent of y over x. They're already labeled for you. Y is -5. X is 3. Now, when we type that in, think about the shortest way to get to that point when you rotate. This would have to be a little longer, but if you rotate, that's going to be the shortest direction. I mean, you can go the other way, but the calculator is going to give you the shortest way. What kind of angle would you expect the calculator to give you when I type this in? Yeah?
Negative.
Negative, and it is. It's going to give you a negative angle. Because remember, it always gives you an answer between -90 and 90. It's not going to give you like 200 and something degrees. Inverse tangent of -5/3. -59.04. And that's fine. If they don't say you can't, if they say negative angles are okay, then use it as a negative. But what if they want it positive? How would you convert that angle so you're going the other way, positive way? Yeah?
Add 360.
That's an add 360. That's not something we learned today. It's something we've learned at some point in the past 3 chapters. So that's the same as 300.96. Okay, so there's my angle as a positive. And what's the equation that I use? To solve for the radius. Yep, got it. Can you tell me what it would be using my numbers?
3 squared plus 5 squared.
3 squared plus 5 squared, yep. And what does that equal? Think about what we're solving for.
C squared.
C, yeah, we're going to call it R just because it's the radius. 3 squared is 9. 5 squared is 25. So R is the square root of how much? Okay.
34.
34. There you go. Just write that as a coordinate, and you're done. Final answer, R, comma, theta. And that's how you convert to polar. Questions on that? Okay, so tomorrow we'll finish up 9.2. And then on Thursday, the plan is to do 9.4, part 1. Okay, so that's the homework for tonight. Okay, 492, 1 through 14. Okay, so 1 through 14.